Hi students, so I know this video is so late. I was not okay. So today we are going to start the next session, that is we are going to learn about chemical equations, different type of chemical equations, and we'll try to balance them also, because last class we already have discussed about the radicals and so on things. So hope you are revising, and now let's start with the chemical equation, because already we have learned about chemical formula, molecular formula, all those things. So now let's write chemical equation. Okay, so let's say chemical equation. Okay, chemical equation. Hope you can understand my handwriting. So chemical equation basically the representation of a chemical reaction. In very simple, it is the representation of a chemical reaction. Okay, chemical reaction. We'll take simple examples that we can understand later when we are going to discuss about the questions and some PYQs also. That time we are going to discuss about the questions that are very necessary to us, but for now we'll take simple examples. So representation of a chemical reaction. First of all, I know you are confused about what is chemical reaction. देखो, chemical reaction is a process of formation and making of bond. Chemical reaction is a process of formation of new compounds, process of formation of new compounds from the reactants, that means let's say A plus B gives rise to AB. Okay, so A is a reactant, B is a reactant, this is a new substance, right? Because AB may be different, may be similar, so that's why I have written as formation of new compound. Okay, formation of new compounds. So this is what the chemical reaction is. Okay, this is what the chemical reaction is. In this case, what happened basically, there is breaking of bonds, breaking or making of bonds, you can say breaking and making of bonds. Okay, breaking and making of bonds. So this is what your chemical reaction is. Now let's take a simple example, like let me tell you actually कि when hydrogen reacts with oxygen, it or when hydrogen reacts with oxygen, the product formed is water, right? Is water. Okay, so this is what the chemical reaction is. Okay, this is what the chemical reaction is, but the point is how to write this, right? So there are three ways of writing it. Actually there are two ways. One is valence chemical equation. So first let me write the word form of a chemical equation. Okay, so the first type of chemical equation is known as word equation. Okay, word equation. Okay, word equation. So what is word equation? Representation of a chemical equation by the names only. Representation of a chemical reaction by writing their names only is called word equation. Word equation. Okay, word equation. Okay, let me write. As I said, when hydrogen reacts with oxygen, produces water, right? Produces water. Okay, so this is the word equation. Let me write one more example, that is hydrogen plus nitrogen. Okay, hydrogen plus nitrogen gives ammonia. Okay, gives ammonia. Okay, let me write calcium carbonate gives rise to decompose to give calcium oxide plus carbon dioxide. Okay, calcium oxide plus carbon dioxide. So this is what a word equation represents, or how to represent the word equation. This is the process that you should represent a word equation. Okay, that's very simple, nothing to worry about it. Okay, next what sorry for the disturbance actually. Next, what is there called skeletal equation. Okay, skeletal equation. In this process, what we have to do, we have to convert this word equation into first a chemical equation, then I'll tell you what is a skeletal equation. So let me write the word equation for you. That is hydrogen plus oxygen gives rise to water, right? Hydrogen plus oxygen gives rise to water. Acha, देखो, now you have to remember some rules actually, some rules to write a chemical equation. Okay, rules to write a chemical equation. This is very important actually, because most of the students make mistake in this actually. Okay, so whenever you are writing a chemical equation, use only molecular formula. Okay, use only molecular formula. Second thing, chemical equations for you. So this is what hydrogen plus oxygen gives rise to water. Okay, gives rise to water. You see, the molecular formula of hydrogen is H2, the molecular formula of oxygen is O2, and the molecular formula of water is H2O. The molecular formula of water is H2O. Let me write ferric chloride plus sodium hydroxide gives rise to ferric hydroxide plus sodium chloride Okay, so you see, this is ferric chloride means FeCl3. Okay, then sodium hydroxide, that is NaOH, gives rise to FeOH whole thrice plus NaCl. Okay, plus NaCl. So this is now the skeletal equation. Okay, this is now the skeletal equation. Okay, so why I said it so? Because you see, these chemical equations are not balanced. Okay, these chemical equations are not balanced. Now, what did you understand? That skeletal equations are the skeletal equations are the imbalanced chemical equation. Okay, imbalanced chemical equations. So these are what skeletal equation is. Okay, so now let's move on to balanced chemical equation. That is from skeletal equation. Okay, now let me write balanced chemical equation. Okay, balanced chemical equation. So let me write a skeletal equation like FeCl3 plus NaOH gives rise to FeOH whole thrice plus NaCl. Okay, NaCl. How do you know that this equation is not balanced? Just calculate the each kind of atom here. Okay, each kind of atom. So this is reactant side, this is product side, right? If I am talking about iron, that is Fe, how many are there in the reactant side? 1, and in the product side also 1. Similarly, for chlorine, how many are there? 3, and that side it is 1. Then for sodium, how many are there? 1, that side 1. Okay. Then for oxygen, how many are there? This side 1, that side 3. Okay. Then again for hydrogen, this side 1, that side 3. You see, few elements are there like chlorine, then oxygen, and then hydrogen. These are not equal. Okay, these are not equal. We have to make this equal. That's why this is called balanced chemical equation, because both the sides you should have each kind of atoms in equal numbers. Then only this is said to be a balanced chemical equation. Now let us understand what is a balanced chemical equation and why we call it so. देखो, balanced chemical equation means number of atoms of each kind should be equal in a reactant and product side. Reactant and product side. Then only you can say that is balanced chemical equation. Next, why it is necessary? Why is it necessary to balance a chemical equation? Okay, to balance a chemical equation. Okay, to balance a chemical equation. देखो, the answer is very simple. To satisfy the law of conservation of mass. Law of conservation of mass. So what is law of conservation of mass again? That mass, or you can write matter also, matter cannot be created nor be destroyed. ओके, तो मतलब मेटल को ना बनाए, मैटर को ना बनाया जाता है ना जा सकता है ना क्रिएट किया जा सकता है. सो दिस इज व्हाट मैटर और मास कैन नॉट बी क्रिएटेड नॉर बी destroyed. So in order to satisfy this concept, we should balance a chemical equation. Okay, I hope you understood this. Now let's write the steps to balance a chemical equation. देखो, there is no particular step. We are going to write different I'll teach you 3 types of chemical equation. Okay, one is heat and trial method, second one is your algebraic method, third one is your partial equation method. So for this class I'll be teaching you only heat and trial method. In other means in the next class I'll be teaching those two, or in separate classes I'll be doing that, right? So first of all, the type of equation is known as heat and trial method. Okay, heat and trial method, or it is also known as trial and error method. Okay, trial and error method. Suppose let's say this is a pole. Okay, this is a pole and there is a naughty boy. Okay, he is throwing the stones to this pole. Okay, until unless it strikes this pole, he is continuously throwing the stones. Okay, so this kind of balancing equation is like this only, means you have to put the coefficients or the numbers in order to balance a chemical equation. Okay, so there are certain rules, means it is not the universal rule. This is my rule, or most of the people use this rule to balance the chemical equation, because this makes a little easier to balance it. Okay, so first of all, balance the metal. Okay, balance the metal. Okay, then second, you have to balance the non-metals except oxygen and hydrogen, thirdly, balance oxygen, and the last one is balance hydrogen. Okay, balance hydrogen. So this is the sequence you should follow, right? Now let me tell you how we should follow this, how to understand this. Let's say you have some metal, so you have to first valence the metal one, okay, then non-metal except oxygen and hydrogen, except oxygen and hydrogen, then oxygen, then hydrogen, okay, then hydrogen, right? So let's say your metal is valence, then you have to get back to non-metal. After balancing non-metal, if you see any changes in non-metal, you have to go back and check whether there is any changes occur in metal or not. If there is no change, then you have to get back to oxygen. Then again similar process, if there is some change in oxygen, you have to go back to metal first to see whether there is any change in metal or not. Then you have to go back to non-metal. If there is no change, then you have to get back to hydrogen. Similarly, if there is any change in hydrogen, you have to go back to metal, then non-metal, then oxygen, okay. So this is the step, or these are the steps you should follow to clarify or to get better into the balancing equations, okay. So now let me write few equations. By writing few equations we'll be solving it, then we are heading towards next class to balance the chemical equations by algebraic method and partial equation method, okay. So let's say take a very simple chemical equation, that is H2 plus O2. You are thinking, sir, you are not taking difficult equations. As I told, I will be discussing in the question answer session, okay. Means when we are solving the questions, we will be doing that time, okay. You have a lot of chemical equation in your book, so we will be doing all those. H2 plus O2 gives H2O. Acha. Can you find any metal here? No. Can you find any non-metal except oxygen and hydrogen? No. So now the next one is your oxygen, right? So let me write this reactant, this is product, okay. How many oxygens are there? 2, and this side it is 1. Then for hydrogen, how many hydrogens are there? 2. As I told, number of atoms, so that's why I am writing number of atoms, and hydrogen also 2. The point is hydrogen is balanced. Now what we need to balance, that is oxygen. So multiply this oxygen with 2. When you are multiplying this 2, you have to apply this 2 here, okay, but don't write this, don't write it as the subscript of 2, write here, because oxygen in the product side is is inside a molecule, right? So you cannot simply write 2 here, that will be not correct, okay. So now you see, after putting 2, I have to multiply 2 with this hydrogen also, this will become 4 now. So you have to make this hydrogen 4, that means I have to multiply 2 here, okay. So again I will put 2 here. So now you see the equation is balanced, okay, the equation is balanced, understood. So next, let's say FeCl3 plus NaOH gives rise to FeOH whole thrice plus NaCl. So you see there are few metals and non-metals. So first one is your Fe, second one is your sodium, then chlorine, then oxygen, then hydrogen, as I told the sequence. So this is the reactant side, this is the product side. How many? This is 1, this is also 1. How many? Means sodium, I am talking about iron, sodium, right? So this is 1 and this is also 1. So how many chlorines are there? This side it is 3, that side it is 1. How many oxygen are there? This side it is 1, that side it is 3. How many hydrogens are there? 1 and 3, right? So देखो, iron is balanced because 1 and 1. Sodium is also balanced, 1 and 1. But the point is chlorine is not balanced, okay, as it is 3 and it is 1. So you have to write 3 here. So if you are writing 3 here, then you see chlorine is balanced now. As I told, after putting or after balancing the non-metal, we will see the metals if there is any change or not. For iron there is no change, but for chlorine, but for sodium it is 3, means this sodium will become 3. So in order to balance this sodium, we have to write 3 here. Now you see, when I am writing 3 here, the sodium is now balanced. Now you see, 3 oxygen means I have to multiply with this also, and for hydrogen also. Now you see everything is balanced. This is 1, this is 3, this is chlorine again here 3, I forgot to write 3, this is 3, this is 3, both side you see. Okay, so now this is balanced, so I can write FeCl3 plus 3 NaOH gives rise to FeOH whole thrice plus 3 NaCl. So this is what your balancing a chemical equation by heat and trial method. Okay, next question, let me write KNO3 gives rise to KNO2 plus O2, right? So now let's write for potassium, then nitrogen, then oxygen, because hydrogen is not there. So this is reactant side and this is product side. So potassium is 1, this is also 1, nitrogen 1, this is also 1, this is 3, and this is the curve. When you can see this kind of representation, देखो oxygen represented separately, so you also have to write in a separate form, that is 2 plus 2, no need to write twice, you write simply 2 plus 2. Okay, so potassium is balanced, nitrogen is balanced, the point is oxygen is not balanced. So in this case use your common sense. I always say my students, use your common sense. Okay, I know I am not degrading myself, but the point is that I am not very familiar to online teaching, so I am newly I am teaching. Okay, so there are some flaws in terms of my wordings and so on things, but my teaching is as perfect as an educator who is teaching in online classes. So try to understand that what I am saying, don't go to my words and sentences, please follow what I am saying. Okay, so this is 2 and 2. Okay, so 4, you see this is 3, we cannot make 3 to 4, either we can make 3 to 6, 3 to 9, right? So let's try it as it is written triangle. So if it is 3, let me put 2 here. When I am putting 2, this 2 3 becomes 6. Clear? Now you see after putting 2, this nitrogen become 2 and this potassium also become 2. Okay, so in order to balance these, as I told you, to get back to metals, then non-metals, if there is any changes we have to balance in, then again get back to oxygen or whatever other things are there. So we have to multiply 2 here, also you have to multiply 2 here. Now 2 means I have to put 2 here. Okay, as I have multiplied 2 here, that means I have to multiply 2 to this 2 only, right, not to this. Okay, so now you see for potassium there are 2, this side also 2, for nitrogen this is 2, this is 2, and for oxygen already I have put 2, so 3 into 2 is equal to 6, this is 4 plus 2 is equal to 6. Okay, this is 6, this is 2, this is 2, this is 2, and this is 2. So now everything is balanced and this equation is also balanced. Okay, so thank you very much, hope you understood. Okay, and again I will say, please don't consider my flaws, I am teaching newly in online platform. Please support and like, share, and please see the complete video of mine. Okay, thank you so much, we'll meet in next class.